Okay, so here we go with our fourth lesson. We're looking now at multiplying and dividing rational expressions. So we just finished lesson 3, which means we know now how to simplify our expressions. So from there, dividing and multiplying is not that difficult, especially if you know how to multiply and divide fractions. Very straightforward. We're going to follow the same procedures. And we're just going to look at what do we do with the non-permissible values here. So they do give you in your notes, they do tell you like there's some steps to follow. I will be following those steps and we'll kind of see how things look as we go here. So the first example, of course, is just a fantastic reminder of how do we multiply fractions, right? Numerator times numerator, denominator times denominator. It's too many words for me, so I just like saying top times top and bottom times bottom. And that's it. Then we simplify. So 4 times 9, 36. 3 times 2 is 6. I take a look here, I got 36 over 6. Can I simplify? Of course I can simplify. The answer is 6. There you go. So if you know how to do this, and you know how to multiply binomial by a binomial, so on and so forth, then this lesson should not be a problem for you in any way, shape, or form. So the only thing we're going to have to really watch for is those non-permissibles. So first thing we're going to do is I have this equation x squared minus 4 over x plus 3 times x squared plus 6x plus 9 over x plus 2. So the first thing we always going to have to do before we do anything else is we need to simplify this first, or factor it out, break it apart. You're going to really see lots, so be prepared for these. Is going to be the difference of squares thing that will happen here with x squared minus 4. We need to be able to recognize that right away. Now we have x plus 2 times x minus 2, and this is going to be all over my x minus 3. I have an x squared plus 6x plus 9. All I got to do now is expand that, and again, this is going to work out to be a perfect square, but I'm going to write it out. Instead of writing x plus 3 squared, I want to write it all out so we make sure we see everything visually. So this will be times x plus 3 times over x plus 3 times x plus 3 over x plus 2. Now that we have it factored, now we can find what our non-permissible values will be for the rest of this question. So of course x can't equal 3, and here x cannot equal negative 2, so we can add that to our answer. Now because we're multiplying, right? So this is the problem with using x's for multiplication. Of course, now we have x's and multiplication, so it's this times this, so it's x plus 2 times x minus 2 times x plus 3 times x plus 3 over x minus 3 times. So again, it's pretty repetitive. Now we can clear off stuff, right? So again, I have an x minus 3. Do I have any other x minus 3s? That I do not. Do I have any x plus 2s? I do. X plus 2 over x plus 2. And I want to look at this original question. Was I supposed to write x minus 3 on that one? No, it was x plus 3. And then, oh, I did. I just wrote a wrong one here. Hey, I knew something was fishy. So again, now I have an x plus 3 denominator and one of the two numerators. So those are crossed off. My denominators have been officially gone. That's 1. I don't need to write them. So my final answer is the x minus 2 times x plus 3. And again, I'm not going to re-multiply these. I'm going to leave these in this form, and all I'm going to do now is state my non-permissible values where x cannot equal 3 or negative 2. And that is our completed question. So that is the first. I'll go over the next couple of examples of this second example, and then we can go to dividing, and we'll be through this in no time at all. So we are looking at examples 2b and 2c. So here we have for 2b, again, the way they write this out, and I'm okay with you writing out the long way, we should reach a point where we don't need to. We should be able to jump straight at it. But good practice to see visually what's happening. So this is going to be, right, 3 times 10 30 times x times x times a y. And this is going to be all over. 5 times 9 is 45. Times, there's 2 x's times x times x. 3 y's times y. So they write it out the long way. Not that there's a problem with it, but again, if you can skip this step and just go, I would strongly recommend doing that. We should be able to recognize here that x cannot equal 0, y cannot equal 0. That's a pretty straightforward non-permissible value. And then we can just complete the question as normal, right? We have 30 over 45. It won't disappear. Great English. It won't disappear, but it will simplify. 30 over 45, of course, looking at the value of 15, simplifies to 2/3. So 2 over 3. If I need to, again, I can show my x's crossing off here. So gone, 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 gone. 1x, 2 x's from the top, 2 x's from the bottom, 1 y from the top, and 1 y from the bottom. We're left with 2 y's down below. So 2 over 3y squared. That is going to be our final answer, just in this context. X cannot equal 0. And y cannot equal 0. So nothing too crazy going on in that question there. Takes us to the next one. This is something that you might run into a little more often. Again, there's nothing different here. We have full questions. First thing, let's expand everything. Let's get everything factored first so we can put it in similar form, right? X minus 1 is staying x minus 1. X squared minus 4. Perfect square, difference of squares. X plus 2 times x minus 2 times x squared minus x minus 6. So this is going to be -3 and plus 2. (2x squared minus 2). This is the one we're going to have to watch out for because we can divide 2 out of both of these. Let's get rid of that 2. And that's going to leave us with an x squared minus 1. So it didn't look like it was simplifiable in the first place, but after we factor the 2, now we see an x squared minus 1. Keep that one in the head because that one shows up often. We see x squared minus 1, we have to realize that that is also a difference of squares. That can still be expanded, right? We can use the x plus 1, x minus 1. So, because I'm multiplying, I'm just slamming them together. X minus 1 times x minus 3 times x plus 2. Oh, and I skipped a step. Oh, no, I didn't. Over x plus 2, x minus 2 times the 2 times x plus 1, x minus 1 So it looks long and complex, and I might even look here. I'm going to try and slide this here. Maybe we can get a little more in focus here. So at this point, I can now start looking for what some of my non-permissible values are going to be. Because now it's fully factored. Now I can do this. So I know that x cannot equal minus 2. Cannot equal plus 2. That's the 2, so we don't worry. It cannot equal minus 1. It cannot equal 1. So I have 4 non-permissibles that I can add in at the end, and in the end I'm going to write them from least to greatest, just again to make it easier to follow. My next step, of course, is just going to be crossing off what's redundant, right? Repetitive on top and bottom. And I have an x minus 1 and an x minus 1. Gone. An x minus 3, it's alone, it can stay. An x plus 2, I have one down here as well. Now everything is, of course, a little more cleaned up. We just have to rewrite our final answer. So I have an x minus 3 left. And I have an x minus 2, a 2, and an x plus 1. So I'm going to write the 2 first. The x minus 2 times x plus 1. And I'm running out of room pretty fast here, and it's getting blurry again here. And this is going to be where x cannot equal -2, -1, 1, or 2. So again, I'm getting a little fuzzy. Sorry, I ran out of room on that one. Some of these questions, that's the only thing you're going to have to get over, is that it might take up a little more paper than you're used to. Be prepared for that. If you get over the complication of how much you have to write down, you're going to see that the work is not hard. There might be a lot of just writing to do. So that is our example 2. We will reset and we will look at example 3. Same process. Now we're just going to be dividing instead of multiplying. As we move on now to the third example, again, it's a straightforward, just fractional. 4/3 divided by 6/5. It's a good review on how do we divide fractions. As long as we remember, find the reciprocal, multiply. So 4/3 divided by 6/5. We can say times the reciprocal, which is 5/6. And then we just proceed as normal. 4 times 5 is 20. 6 times 3 is 18, and simplify. Always we're simplifying as we're going. 20/18 will of course simplify to 10/9, and I'm okay with right now we're going to leave this as an improper fraction. Just we're going to keep going with these later. So that is a review on how to divide fractions. So now let's do the same thing but with our rational expression, and then we'll see if anything new comes up here. Same procedure. I have x squared minus 4 over x plus 3 divided by x plus 2 over x squared minus 9. I need to factor to make sure this works. So x squared minus 4 does in fact become x plus 2 times x minus 2. X plus 3 remains. I'm going to divide this by x plus 2. And x squared minus 9 is a difference of squares again, x plus 3, x minus 3. At this point here, of course, I have it factored out so I can find non-provisionals. So put a little NPV here. X cannot equal -3, -3 again, and a plus 3. So I have 2 non-permissible values there so far. But I'm going to take this equation, I'm going to have the x plus 2, x minus 2 over x plus 3 divided by x plus 2 over x plus 3, x minus 3. Same thing. I'm just going to divide this first chunk by the reciprocal, so I got to flip these around, which means again some rewriting to do. Over x plus 3. Now the reciprocal, so I'm going to multiply, so times, so now the x plus 3, x minus 3 go on top. And the x plus 2 is going to flip to the bottom. And the thing is, I've introduced new denominators. I have now introduced new non-permissible values. So this one stays the same, but I now also have an x plus 2 showing up as a denominator, so I will have to say, well, then x cannot equal -2, and that will be added to my list. All right, now that that's done out, now I can start simplifying, right, getting rid of some stuff here. X plus 2 and x plus 2, x plus 3 and x plus 3. I've gotten rid of all my denominators, so they'll be equal to 1. So my final answer for this, and I'm going to run out of room, so I'm going to write it below, is going to become the x minus 2 times x minus 3, where x cannot equal. And again, I'm going to put this in order from lowest to greatest, least to greatest, so it's going to be -3, -2, or +3. And there is my final answer for, what is it, 4? 4A. So I will clean up the board. We will take a look at 4B, and we are going to be well on our way. Okay, so now we can look at examples for B and C. Example 4b here, you notice we're going to have two variables instead of just the one variable, and that can be a little confusing and sometimes overwhelming for people. Don't let that mess you up. If you ever see something like this, just try to apply what you know and see what happens. And quite often it actually works itself out and you'll surprise yourself. It's more or less just getting over the hump of what it looks like, attempting the question, and you'll see you know more than you think you do. So when I'm looking at this whole x plus y over x squared divided by x squared minus y squared over 4x, what can I do with this? I'm looking at the x plus y starting. Can't really simplify that. That's as simple as it goes. Over x squared, I can at least write that as x times x. So let's try that. Okay, so that is going to be as far as we can go. Now I have also the divided by. I have an x squared minus y squared. Again, perfect square, we're subtracting, so we're finding the difference. This is still a difference of squares. That's going to be one to be watch out for. That is a consistent go-to. So I can make this x plus y times x minus y, and I get that difference of squares going. My 4x, again, if I want to break these separately, I can have this 4 times x. Do we need to? Well, we can look at why we would later, very shortly. But before I take it to the next level, I have this as simplified as I can go. I need to start looking for NPVs. So far, all I know is that x cannot equal 0. That's it. Okay, now this is a division, so let's flip and multiply, right? So the x plus y stays the same. The x times x stays the same. This is going to become 4 times x on top. And this becomes x plus y, x minus y on the bottom. Now it starts to make a little more sense. You're going to start saying, oh, there's going to be some stuff I can cancel out here, right? X plus y, I have 2 of those, so that's gone. I have a 4, no other coefficients or numbers, constants to break apart, so that'll stay. I do have an x in the brackets, they're separated. Again, this is just a good reminder that that one x can take off one of these 2 x's. I now have left the 4 on the top, and I have an x and an x minus y on the bottom. And I just realized what I didn't do. Should I? This is going to get a little crowded, perhaps. So 4 over x times x minus y. I noticed here in this chunk, I didn't find my when I did the reciprocal, I did not find the non-permissible values here. Did I introduce any new ones? Yes, I did. I introduced that x cannot equal x. Rewrite this properly. X plus y cannot equal 0, and x minus y cannot equal 0. Right? I can still solve these, flip these around to solve for x. So where x cannot equal y, and negative y, and x cannot equal y. So those are going to be 2 more non-permissibles that we can add to this. So my final answer, yes, it would be the 4 times x minus y, 4 divided by x times x minus y. But my non-permissibles I'll have are x cannot equal 0, x cannot equal negative y, and x cannot equal plus y. So there are some non-permissibles that we still have to keep in mind on that question. As I have that, I'm going to be cutting. I have them written down. Hopefully you do too. I will erase these off the board for the time being, so I leave room for my next question down here, which is going to be 4c. So x squared plus 3x over x squared plus x minus 6 divided by x squared minus 2x over x minus 4. Again, so I'm going to work through this one a little bit faster because there's nothing really new here. It's just going to be a lot more factoring. Good practice. Oh, I just wish that it wouldn't get so blurry when I'm trying to write my answers for you guys up there. I just can't seem to fix that. Okay. So here we go, just some factoring, x squared plus 3x. I can take the x, so x times x plus 3. X squared plus x minus 6 is going to be plus 3 minus 2. Divided by x squared minus 2x, again it's going to become x times x, x minus 2 and over x minus 4. So again, non-permissible values. The sooner you cover them, the better you are. So x cannot equal negative 3 plus 2 or plus 4. Find the reciprocals of this. X times x plus 3 over multiply this by the reciprocal, x minus 4 over x times minus 2. And we can see what we're doing with this. So we have this all stretched out. Start looking for things I can cancel out. The x and the x, the plus 3 and the plus 3. I have a minus 4. I have a minus 2. I can write this, when I write my final answer, I can write this as minus 2, or I can write, or sorry, x minus 2, or I can write it as x minus 2 squared at this point. I still prefer writing it the long way, but I should have been canceling out my permissible values again. Right, did I add any? So I got the plus 3 covered, the negative 2 is plus 2 covered, x cannot equal 0. And the x minus 2 is a plus 2, is already there. So I did add one more non-permissible value, which can lead me to my final answer now. So x minus 4 over x minus 2 squared. Which again, you can write it as squared or you can write it as such, where x cannot equal. So I'm going to write this as negative 3, 0, 2, 4. And there we go. So one last one for example 4. This one looks worse than it is as well. It's about how it's presented more than about the work itself. And then we have an example 5. Hey, we are well on our way for being done this lesson. Okay, and as we look at 4D, you'll probably see why this one got its own space on the whiteboard. We have this big one here. It's going to be x squared minus 36 over x squared minus 49 over x squared minus 12x plus 36 over x squared plus 14x plus 49. Can seem confusing and overwhelming again. The way I can remember this is going to be a rational over a rational. I left myself room for this one because there's a way, this looks confusing, but if we can write it in a familiar context, then we will not have as much of a problem. All I'm going to do is rewrite the exact original, and I'm going to rewrite it as linear, right? I'm going to move this up here with a divided by symbol. As long as we know that the fraction is dividing, we can move that up. So myself, I like to do this. I'm going to do this the long way here. Again, I'm going to say this is where, okay, so I'm going to rewrite this as x squared minus 36 over x squared minus 49 divided by x squared minus 12x plus 36 over x squared plus 14x plus 49. There, and I just rewrote that same equation, and I just wrote it in a more familiar way, and I wrote it in a linear fashion. Myself, what I would do is, what I'm going to write next is where I would go to. I know I'm going to rewrite it linear. Why not factor as I'm rewriting it? So this is where I would start originally myself. So instead of, just to try and not take up as much space, I'll erase this. And when I do rewrite this, so I'm going to say, well, I'm going to rewrite it the same way. So x squared minus 36, I'll factor that now. That's a difference of squares, x plus 6, x minus 6. So that one's rewritten. X over x squared minus 49, another difference of squares. That one's rewritten. I will now write this divide sign, and I can rewrite this as a factored version as well. So x squared plus, minus 12x plus 36. That's going to be a perfect square. Of x minus 6 times x minus 6. And that one's now written. And it's going to be x squared plus 14x plus 49. And I'm going to write that as the denominator down here. So that will become another perfect square, x plus 7 times x plus 7. So there we go. I have it written and factored, written in a linear fashion, easier to handle, and factored at the same time. And then I can also go straight to my NPVs with this, where x cannot equal plus or minus 7, and x cannot equal plus or minus 7. So okay, I got a couple of NPVs there. Now I need to find the reciprocal. So this is going to become x plus 6 times x minus 6 over x plus 7 times x minus 7. So the x plus 7 squared goes up top. The x minus 6 squared comes down. So yes, I did introduce a new value as a denominator. I will have an additional NPV where x cannot equal 6. But now I can just simplify this and write my final answer. So x plus 6. Yes, no, I do not have one to get rid of. X minus 6, I do. X plus 7, I have one to get rid of. X minus 7, no. So I'm looking at a final answer of x plus 6 times x plus 7 over x minus 7 times x minus 6. Doesn't matter how you write this, it's just, there we go. And now I'm just going to add in my, not restrictions, NPVs. X cannot equal minus 7, 6, or 7. And there we go. So that one, again, looked more complex. As soon as we get rid of the fraction of a fraction appearance of it, then it becomes a little more straightforward to deal with. Again, put things in familiar context, you'll have an easier time with them. Which just takes us to the last example here, and I was peering over. So example 5, for what value of x is the following expression not defined, simplified. So this is much the same thing. I'm not going to go over this example on here because it would take some time, but it's just a matter of it's looking for NPVs. If you still need help looking for NPVs, let me know. I can help you find them, but that's all it is. Check out the answer key for that one, and if you have any questions, send me a message. Okay, with this, you should be good to go to assignment 2.2. I will shortly have the video for the last one, lesson 5 going, and we can work on the final lesson for this module. So, moving like rock stars.